Voici une présentation de 4 contenus produits lors de l'événement IST 160 Big Data et Intelligence artificielle pour la prise de décision militaire. Tout d'abord, une introduction en langue anglaise de Robert Bond du MIT sur ce qu'est l'intelligence artificielle ainsi qu'un bref historique.
So first of all, what am I talking about when I'm talking about artificial intelligence? You look at the human spectrum of intelligence. We hear, see, smell, touch, taste, and we take that in and we orient and make sense out of that and then decide what we need to do and then we act. So a machine does the same or can do the same thing, collecting data, applying its software, and then actuating or communicating in some way. You read in the press about what's called general AI, and here I define that as the computer being able to achieve human or superhuman intelligence over the full range of cognitive tasks that a human can do. In my personal view, the techniques that we have on the table today in AI don't actually show a clear path to getting to any general AI capability. Some people might say, well, it's just a matter of scale and time, and we'll continue to apply these techniques, and our computers will get faster, and our systems will get bigger and more capable. But from my own experience in this area, I detect that there are some fundamental cognitive, let us say, gaps between the systems we have today and where we want to go to get to general AI. So it's a real challenge, and people are taking up that challenge. Brief history of artificial intelligence, just put a few bullets on here to actually show that it's only in the last decade or so that we're seeing this huge upsurge in AI capabilities, and in particular in machine learning and deep learning, which is only, machine learning is only a subset of AI, and deep learning is a further subset of machine learning. But nevertheless, this has almost become synonymous in the public's eye with AI capabilities.
Puis, quelques slides de la présentation de Karel van den Bosch et Adelbert Bronkhorst de TNO, l'organisation néerlandaise pour la recherche scientifique appliquée. Pour eux, 3 principes clés à respecter pour permettre la collaboration homme-IA sont la prévisibilité, la délégation mutuelle et l'explicabilité. Ils établissent 3 stades de collaboration. À ce jour, nous en sommes au premier niveau, une relation unidirectionnelle à une boîte noire, ou au mieux, une IA quelque peu transparente. Nous devons œuvrer à atteindre le deuxième niveau, une relation bidirectionnelle où l'IA est capable de fournir des explications à ses prises de décision. Et nous pouvons d'ores et déjà anticiper le troisième niveau, celui d'une véritable collaboration où l'homme et l'IA se répartissent les tâches selon le contexte et partagent les mêmes représentations. Afin de parvenir à cette collaboration, Leslie Blaha, du Laboratoire national du Pacifique Nord-Ouest, nous indique en langue anglaise la nécessité de considérer le système dans son ensemble, à savoir l'homme, la machine et leurs interactions. Elle fait notamment référence au cycle de décision OODA, Observe, Orient, Decide, Act, OODA, proposé par le pilote de chasse John Boyd de la Force aérienne des États-Unis.
Okay, so I'll start with a reminder of what the human OODA loop really entails. And I like this particular diagram for human OODA loops because it really breaks down what's happening inside the system. It's not just about a repetitive cycle, but it's harvesting the data. I really like that term, harvesting the data, in the observe process, and then bringing it into this orient stage. Orient is where we make sense of everything. And it didn't happen often when he talked about it, but in some of his presentations, Colonel Boyd breaks down the processes and the things that we bring to bear when we make sense of information. So that includes the new information coming into the system, but it includes all of our genetic heritage. This is how we perceive the world, all the cultural traditions, the languages we use to describe things, the ways we know how to analyze and synthesize information, and then everything we've ever done in the past comes to bear. We bring all of that together in this very mushy, squishy, cognitive brain space, and somehow out of that we predict what's going to happen, and we make decisions about it, and we take actions, and all of this is happening in this dynamic process. And what was particularly key to the way we've argued about using OODA loops is that we don't want to just use it as a way to understand our own personal decision making. We want to use it as a framework for thinking about everybody else. And this is where starting to think about how humans and machines on the battlefield raises a question of how do we really think about machines? It doesn't make sense to have machines with a genetic heritage to it and cultural traditions. It doesn't necessarily make sense to think of them in exactly the same way, but we want them to operate in the same way. We want to disrupt the machines of our adversaries, and we want to work cooperatively with the machines of our allies. And so to get there, I think we need to introduce a concept for a human, or a machine OODA loop that complements our human OODA loops. It doesn't change much thinking about OODA loops for machines in this way. What we have to critically do is start replacing what's going on inside that orient phase that's unique to the machines. What's important about taking this type of perspective and thinking of our systems is that if we start leveraging thinking about the fundamental elements, the way the human and the machine need to interact, and bringing things like process algebras to bear as we develop these full systems, is that we can start to predict things like where the bottlenecks are going to be, and where the system might fundamentally break down. Or have I even set up this system to really work the way I intend it to work, given the capabilities that we're developing with all our new artificial intelligence? And so thinking about our ability to potentially start designing systems where we can predict bottlenecks, predict breakdowns, predict where things might go out of the loop, we should also be simultaneously asking the questions of, are we designing systems and selecting the right technologies with both the human and the machine loops working in the right way?
Enfin, voici les résultats de l'étude de Thomas Powell de l'Université d'Amsterdam et Philippe Hellès de l'Agence de communication de l'OTAN qui ont déterminé des groupes d'opinion au sein de la population afghane. Pour ce faire, ils ont appliqué une classification non supervisée selon 4 axes sur les résultats de sondages d'opinion. Ils ont ainsi obtenu 6 clusters, 6 groupes, projetés ici sur les axes correspondant à l'opinion quant au gouvernement et à leur sentiment de sécurité. En comparant le profil des 6 regroupements aux données de la population afghane, ils ont pu identifier un profil général pour l'ensemble de ces 6 groupes.